This is the video lesson for solving horizontally launched projectile motion problems. The learning target for this lesson is, I am learning to calculate the starting and ending velocities, horizontal distance, initial height, and hang time of a horizontally launched projectile. The success criteria for this lesson are, I can calculate the starting and ending velocities of a horizontally launched projectile. I can calculate the horizontal distance traveled by a horizontally launched projectile. And I can calculate the initial height of a horizontally launched projectile. Lastly, I can calculate the hang time of a horizontally launched projectile. For horizontally launched projectiles, for the position, x0 is the initial horizontal position, and x is the horizontal range. That's how far the projectile is moving in the horizontal direction. For the velocity, you have v sub x, which is the constant horizontal velocity. And then for the acceleration, you have no horizontal acceleration. And then for time, you have t equals time. So these are the important things that you need to know for the horizontally launched projectiles. You're also going to have to figure out the time that it takes for the projectile to fall, usually. All right, let's look at example problem number 1. So a vase is pushed off a 3-meter tall cabinet by a cat. The cat pushes the vase off with a horizontal velocity. So we have a horizontal velocity here of 4 meters per second. Determine how long the vase took to hit the ground. So how long? So we're talking about the time here. The horizontal distance traveled. So this is talking about the range. And the final velocity, the final vertical and horizontal velocities. So vertical and horizontal velocities of the vase just before it hits the ground. Okay, so here is a bookshelf. Here is our vase. It's got pretty flowers coming out. And here's our cat. You, of course, don't need to draw such a detailed diagram, but it does help to draw a diagram sometimes. Okay, and the cat knocks it off. So we have an initial velocity of 4 meters per second. This distance is 3 meters. So we call this y0. And we want to know this distance here. So this is x. This is vx. Okay, so of course our acceleration is equal to minus g, which is equal to minus 10 meters per second squared. Okay, so the first thing we need to know is how long it takes for the vase to hit the ground. So we're going to use y equals, think of it as y equals y0 plus 1/2 gt squared. Okay, so our y is 0, y0 is 3 meters, plus 1/2 g is minus 10 meters per second squared times t squared is what we're looking for. So we have minus 3 meters equals minus 5 meters per second squared times t squared. So divide both sides by minus 5. So we have 3 divided by 5, 0.6. So we have 0.6 seconds squared is equal to t squared. So take the root on both those, on both sides, and we end up with t is equal to 0.77 seconds. Okay, so we've got our answer to how long the vase took to hit the ground. So t is 0.77 seconds. Okay, so now we want to know the horizontal distance traveled. So what is this distance here? So we're going to use x equals x0 plus vxt. Okay, so x is equal to x0 is 0. Starting position is 0. So we have vx, which is 4 meters per second, times our 0.77 seconds. So that's equal to 3.1 meters. All right, so our horizontal range is 3.1 meters. Okay, so if we think about this, let's stop for a second and just think about the reasonableness of this answer. 3.1 meters is a really long way. However, the vase was launched with a velocity of 4 meters per second. So, and the time is a little bit over 3/4 of a second, so 0.77 seconds. So at 4 meters per second, you would expect the vase to travel every second, you would expect it to travel 4 meters. So it travels here about 0.77 seconds, so that's about 3/4 of a second. So after 3/4 of a second, it would move 3/4 of 4 meters, which is a little bit over 3.1, a little over 3 meters. So it seems reasonable. Okay, so now we need to find the final vertical and horizontal velocities of the vase just before it hits the ground. So the final vertical velocity, or excuse me, the final horizontal velocity is exactly what the initial horizontal velocity was, because the horizontal velocity doesn't change. So the horizontal velocity is 4 meters per second squared, or 4 meters per second. Then to get the vertical velocity, we're going to use the equation Vy equals Vy naught plus A sub y times t. So our initial vertical velocity was 0. We're traveling we have an acceleration of minus 10 meters per second squared times 0.77 seconds. So our final velocity is going to be minus 10 meters per second squared times 0.77 seconds. So that's going to give us a final velocity of minus 7.7 meters per second. All right. All right, so here's example problem number 2. We have a B-17 flying over Nazi Germany to bomb a fighter factory. It flies at a speed of 130 meters per second and a height of 7,000 meters. So how far from the factory should the bombardier release its bombs to hit the factory? So we're talking here about how far. So this is the X directions, or so this is the range basically. So how long will the bombs be in the air before they hit the factory? So how long? So we are looking here for X and T. So draw a little sample diagram here. So we have our plane, our bomber, and it's got a bomb on the bottom, or bombs, and it's going to launch the bombs. They're going to travel down here. It's got an initial velocity, Vx, is equal to 130 meters per second. And it's traveling at a height above the ground of 7,000 meters. Okay, so we're looking for this distance, x here. Before that, we're looking for the time that it takes for the bombs to fall. Okay, so again, we're going to use two equations. We have x is equal to x naught plus vx times t, and we have y is equal to 1/2 a sub y t squared. Okay, so first we need to figure out the time. So our y, so we can say we have minus 7,000 meters is equal to minus 5 meters per second squared. So that's 1/2 times -10, and then that's times time squared. So we'll divide 7,000 by 5. So that gives us so we have 1,400, that should be seconds squared equals time squared. So our time then is equal to 37.4 seconds. So the bombs are in the air for 37.4 seconds. That's just based on how high the plane is. It has nothing to do with how fast it's traveling. Okay, now we want to know what the horizontal range is. So our range equation is this one. So say range is equal to, so our x naught is 0. So plus our speed is, our horizontal velocity is 130 meters per second. And we multiply that times 37.4 seconds. Everything's a little squished all together here. So we have x is equal to 4,864 meters. Or put another way, we have 4.864 kilometers. All right, so our time in the air is 37.4 seconds, and our horizontal range is 4.864 kilometers. All right, example 3. A Hot Wheels car rolls off the table at a speed of 2.32 meters per second and hits the floor a distance of 119.7 centimeters from the table's edge. Determine the height of the table. Okay, so we need to recognize a few things here. So we have our Vx is equal to 2.32 meters per second. Our range, our x, is equal to 119.7 centimeters, which we want to convert into meters. So that is 1.197 meters. All right, so we're looking for the height of the table. So we have a table here. We've got a Hot Wheels car that rolls off the table with a velocity of 2.32 meters per second. It has a horizontal range of 1.197 meters. We're trying to find the height of the table. We want to know this y naught equals question mark. So this height here. Okay, so we're going to use the equation x equals x naught plus vxt, and y equals 1/2 gt squared. Okay, so our x naught is 0. Our x is this 1.197 meters. That's equal to 2.32 meters per second times t. So t is equal to 1.197 meters divided by 2.32 meters per second, which gives us a time of 0.516 seconds. Okay, so now we're looking for y here. So we have y is equal to 1/2 times -10 meters per second squared times 0.516 seconds, and let's square that. Y is equal to 1.33 meters. Okay, if you're concerned about this negative sign here, this negative sign, and why we don't have a negative number here, so we can think of this as being y equals y naught. So plus 1/2 at squared. So our a is negative. If we think about our y naught as being the actual height, we move the y naught over to the left side, and y is 0. So we end up with y minus y naught is equal to 1/2. So this term here becomes minus 5 meters per second squared times our t squared. So this whole term is negative. And if the y is 0, then we end up with a negative here and a negative on the left side and negative on the right side. So we just use a shortcut to say that this y is negative. So it cancels this negative here. It's just shortcutting the whole thing so that we don't end up with a negative on one side when we have to do a square root or something. All right, example problem number 4. Someone knocked a tennis ball off of a 109.4 centimeters table, centimeters high table, and it hit the ground a distance of 2.4 meters from the table's edge. Determine the time it takes for the ball to fall to the floor, the speed of the ball the moment it leaves the table, and the speed of the ball the instant it hits the floor. Okay, so we've got let's say a y of 109.4 centimeters. We've got a x, that's the range, of 2.4 meters. We want to know the time, t. We want to know Vx. And we want to know V. So this is the resultant vector. This is not Vy or Vx. This is the composite vector. Okay. So y is equal to 1.094 meters. So we've got our range. So we have x equals x naught plus Vx t. We know the range. We don't have our velocity or time. Okay, so we can figure out our time first. So that will help us figure everything out because we know the height. The height gives us our time. So we have y is equal to 1/2 gt. So that's y is equal to minus 5 meters per second squared. That should be t squared times t squared. So we have 1.094 meters equals minus 5 meters per second squared times t squared. So t is equal to 0.47 seconds. Okay, now since we know the range of 2.4 meters, we can figure out the speed, the horizontal speed of the ball. So we have x is equal to x naught plus Vx times t. So x naught is 0, so we have 2.4 meters equals Vx times 0.47 seconds. So divide both sides by 0.47 seconds, and that gives us Vx is equal to 5.13 meters per second. Okay, I'm going to erase a few things to make room to figure out the vertical velocity, and then we'll figure out the resultant velocity. Okay, so now let's figure out the speed of the ball in the y direction. So we have Vy is equal to Vy naught plus At. So Vy naught is 0. So we have Vy is equal to minus 10 meters per second squared times 0.47 seconds. So Vy is equal to minus 4.7 meters per second. Okay, so now we need to figure out the speed of the ball the instant it hits the floor. So this is the resultant vector. So we're talking about V then is equal to square root of Vx squared plus Vy squared. So V is equal to, so Vx is So the square root of 5.13 squared plus minus 4.17, or 4.7 rather, 4.7 meters per second, and we'll square that. So V then is equal to 6.61 meters per second. All right, now all we're asking us for is the speed of the ball, so we're not asked for the magnitude or for the direction. So V is the magnitude of the ball here, 6.61 meters per second. All right, that's how you solve that problem. All right, so what have we learned in this lesson? We've learned strategies for solving horizontally launched projectile motion problems. So know what variables change and what don't. And we've learned to pick the correct kinematics equations. So you want to use the correct equation based on the given information and what the problem is looking for. All right, thanks everybody.